Hey guys, this is Avinash here. This is my first short story presentation for Compy 255, and the topic is Spark for NLP. Okay, let's get into the topic. At first, what is NLP? Natural language processing is a subfield of computer science, and it is one of the fields that works towards human-computer interaction. Natural language processing tries to build machines that can understand and respond text or voice with text or voice in the much same way as the humans we do. So that's basically what NLP is. NLP is pretty much used in literally all of our day-to-day activities. For example, whenever you use Google Assistant or Amazon Alexa, your voice is getting translated into text, which is getting processed by Alexa or Google. Then it returns back the processed text in the form of voice to the user. And also, whenever you do Google search, whenever you type in a query, the text is getting converted into tokens, which is then understood by machines so whatever your query is mapped with all the documents in the web, and it provides all the list of documents which have a higher cosine similarity or matching it with your documents. So that's one of the great uses of NLP. Okay, now let's go into what are the use cases that are currently employed in NLP. I have just listed a few use cases, but there are literally countless, endless use cases. Okay, first, sentiment analysis. For example, if you are running an e-commerce company or you are developing a product which you are selling on any e-commerce site, you wanted to understand your customers on how they feel about your product. So, what you can do is you can employ sentiment analysis, NLP techniques on top of your user reviews and understand whether users are happy with the product or they are not satisfied with the product. So you get great insights about your product. Now, looking at information retrieval systems, as I said earlier, all IR systems use NLP. For example, as I said earlier, whenever a user type in a query, the query is getting converted into vectors. Then vectors are literally mapped with all the essential documents which are currently residing in the World Wide Web or even in a document repository for a particular organization. Then only the mapping documents are listed out based on Boolean matching or cosine similarity or Jaccard additional, whatever may be the preferred way. And another one of the interesting use case of NLP is paraphrasing or summarizing. For I guess everyone would be aware of an application called InShots. If not, just look into the Play Store. It's a great app where you get news articles in a paraphrased and crisp manner such that you can read all the essential news within a short span of time. An entire news page is getting counted in 2 to 3 lines. So you would get to know what is the core information that is getting shared in the news article. All the Now coming into the chatbots, all the existing QA system and chatbots literally are powered by NLP. So it's one of the great use cases. So now coming back to the early days, one of the first use cases of NLP was spam filters, where what it does it understands the user's email and filters on top of it whether it's a spam or not. It's one of the early and one of the oldest ever first use cases of NLP. Also, you can use NLP for a cognitive assistance where it understands all your day-to-day activities and it can provide recommendations or relevant stuff based on a particular user needs. NLP can also use for prediction. For example, if you run a biomedical organization where you have all the records of all the drugs that you have and all the composition you have, we can also use it for understand the documents and what are all the composition for a particular drug and make prediction whether this composition belong to this drug or not, or etc. There are countless, endless use cases for NLP. Have just listed the few cases that come into my mind. Okay, now let's get into Spark. That's the main part of our presentation. What is Spark? Apache Spark is a lightweight, unified analytical engine for big data and machine learning. It was originally developed at UC Berkeley in the year 2009. Then it was later open source to Apache Foundation. Apache Spark is literally used in every organization right now for processing large amount of data in a distributed manner such that it can scale. All the cloud services which are currently available like AWS, Google, Azure also provide cloud services for running Spark jobs with ease. So Spark is one of the great deals right now. So let's look into a simple architecture diagram of Spark. Here, when you look into the architecture, Spark has a cluster manager with which manages the entire cluster. You can use built-in Spark Cluster Manager or Apache Mesos or even Yarn, which is the current latest industry standard which all the organization use. So your workloads are literally divided into two stuff, a master node and the worker node. Master node is the node where which keep tracks of all the activities, and worker node is the node which perform the data activities. So, for example, if I request for a job to be done, for example, if I pass in a Word document and I wanted to find all the counts for the word hello in the document, then master node would spawn the Spark context, and the actual work will be done by the worker nodes which contain the data. And once the task gets completed, the worker nodes report back to the master node on the completion status. That's literally a basic client server architecture of Spark. Okay, now let's get to our main topic, Spark for NLP. Apache Spark NLP is built on top of Apache YAML framework, so it provides easy to scale, performant, and accurate NLP intelligent for machine learning pipeline in the distributed manner. Also, Spark NLP includes literally thousands of pre-trained pipelines and models in about 192 language. Is pretty much a great deal. It literally supports all the NLP tasks that can be done in the cluster seamlessly without any issues. A great deal of work for Spark NLP was done by John Snow Labs. You can say that they are literally the founders of Spark NLP. You can just look into the website. They are literally the core founders of Spark NLP, and they sourced out to the Apache Foundation. So there are great deal of work done by this team. Also, they have a paid enterprise edition where you get state of the art models for research in biomedical and for OCR too. Just look into the website. Okay, now let me get to the main topic. Why do we need Spark for NLP? I can easily say that Spark is currently the only open source NLP library which provides production grade stuff with state of the art results. Also, it contains all the transformers like BERT, Albert, Roberta, etc., and Google Universal Sentence Encoder for sentence embedding. Not only in Python or but also to any JVM ecosystem. Since literally Spark is written in Scala, which is a Java-based language which interacts in a JVM, so you can write in whatever language you feel the data pipeline. And one great deal is it can scale. Since NLP Spark NLP is going to run on Spark, it can scale seamlessly without any issues. That's one of the great aspects. As you guys would have a lot of concerns on whether there will be all the features that I have in Spacey or NLTK or any NLP frameworks, Hugging Face, etc. Yes, you can. You have literally all the NLP features which are available in the existing libraries in Spark, but even in a better and optimized manner with great accuracy. So you don't have to worry about it. So all the embedding techniques like word to wake, glove, even universal sentence encoder, sentence transformers, all the tokenizers and all the stuff are pretty much available in Spark, and literally everything can be done in just few lines of code with ease without any extra stuff from the user end. Okay, let's now look into the Spark NLP architecture. So when you look into the architecture, when we fit on the pipeline in the Spark data frame, its this column is fed into document assembler. So when it goes into document assembler, a new column document is created as an initial entry point. Once we get the initial entry point, the document column is fed into the sentence decoder module, where the documents are split into large amount of sentences, and there's a new column called sentences which is getting created. Then the sentence column is passed on to the tokenizer, where each sentence are divided into tokens. A new column called token is created. Then the one of the important phase is passing into the normalizer, where the tokens are normalized, just basic text cleaning is done. And finally, the great part is it is passed into the word embedder, or where word embedding techniques are employed, like word to wait, glove, sentence encoder, sentence transform, etc., whatever you wish. Then your document is converted into vectors, and now it is ready to pass into any NLP model that you wish. That's literally the simple and basic architecture of Spark NLP. Okay, as you guys already guessed, Spark NLP is currently the most widely used NLP library in the enterprise. Okay, now let's just see what is next. Currently, Hiking Face is a leading NLP startup with more than thousands of companies are literally using the library for production. So what Spark did is the main great catch with Hugging Face is that you can use all the pre-trained models of Hugging Face with just few lines of code in Python. So what Spark does it also provides you with a framework for modules for importing the transformers Hugging Face library in Spark with ease, and you can use all the built-in train modules like Wobata on Squad dataset or etc. Albert or any other model that you feel in Spark with ease without any issues. Also, thank you for that's all according to me. I want to stop here. Thank you for this wonderful opportunities, and I'm looking forward for other upcoming short story presentation. Bye bye. Signing off.